Hi students, today we will discuss about limit of a sequence is unique. So before going to limit of a sequence is unique, let me know about limit of a sequence. So let Sn be a sequence and a real number L which belongs to R is said to be a limit of a sequence if for given epsilon greater than 0, clearly epsilon. So here epsilon is what? A very small value. There exists m which belongs to natural numbers such that so modulus of Sn minus L less than epsilon for all n greater than or equal to m. See, so what is n here? Which is always greater than or equal to m. So m is what? A natural number. See here, clearly n is the value which is greatest among all m's. So if you take m as a natural number, for suppose if you take m is 100, n is greater 100. So because if you take a maximum n value, then only Sn is very closer to L. If Sn is very closer to L, then Sn minus L is less than epsilon. So clearly n is very maximum. See here, among all m's, our n is a greatest value. So which means that, so here as n value approaches to infinity, clearly, so why? Because n is the greatest value among all m's. So what is m? M is a natural number. Then Sn is approaches to L. So clearly, which means that limiting position of Sn is what? L. So clearly n value approaches to infinity, which means that a very big value when compared to all natural numbers. So that's why I am taking for all n greater than or equal to m. So which means that if you take any value m which is natural, our n is a greatest value among all m's. So then only Sn is very closer to L. Now let us come to the example. A sequence Sn is defined by Sn equal to 1 by n for all n belongs to natural numbers. See here, now if you take n equal to 1, which means S1 is what? 1. S2 is what? 1 by 2. S3 is what? 1 by 3. S5 is what? 1 by 5, which means the value goes on decreasing. So clearly, so what is the range? Here is 1, 1 by 2, 1 by 3 and so on. Now limit n tends to infinity 1 by n, which means Sn. Here it is Sn. So limit n tends to infinity 1 by n is what? As n value approaches to infinity, 1 by n, which is a very bigger value. So 1 by a very bigger value, so gives the result is 0. So now see, if n equal to 1, it is 1. If n equal to 2, it is 1 by 2. If n equal to 3, it is 1 by 3. See this. So as n value is maximum, then only it approaches to 0. So if n is minimum, for suppose if it is 1, then what happens? So 1 is not an approaching value of 0. So 1 by 2 is closer, 1 by 3 closer, 1 by 5 closer, so 1 by 10 very closer. So as n value approaches to, it means as n value is increasing, n value approaches to infinity, then only we get the limit value, which means that, so here n is a maximum value. So clearly n is maximum among all natural numbers, then only we will get the limit. Clearly what we observe, if you take the maximum n, then only we will get the limit. So otherwise it is not possible. So whenever you take n value, it should be a maximum value. Now coming to the theorem. So before going to theorem, so please concentrate on this. As n is a very maximum value, then Sn is approaches to L, or sequence is approaches to the limit. So how much it is closer? You please see this. Clearly epsilon is what? A very small value. So Sn minus L is what? Less than epsilon. So already the epsilon is a very small value, but the difference between these two, the sequence and limit, is what? Less than epsilon, which means that almost negligible, which means so Sn is very closer to L. So whenever when it is possible, as n is a very maximum value. So please understand this concept. As n is a very maximum value, then only Sn is very closer to L. Now coming to the theorem, limit of sequence is unique. Proof. See, let us consider Sn be a sequence. Okay, now let us assume that the sequence Sn converges to two limits that is L1 and L2. So converges is nothing but very closer to L1 and L2, which means almost the limiting position of Sn is what? L1 and L2, which means that L1 is not equal to L2, that is L1 minus L2 not equal to 0. So from this, so the limiting position of sequence is what? L1 and L2. So these two limits are near but not equal. This is nothing but, for suppose if it is L1 and L2, then clearly the distance between these two is what? Negligible. For suppose if it is epsilon. Why? Because the distance between these two is very lesser, which means epsilon. Now let us consider that epsilon is what? Modulus of L1 minus L2, which is greater than 0. It is a positive real number. Now coming to the definition of limit of sequence. So what is the definition? The sequence Sn converges to the limit. For suppose here we take two limits. The first one is L1, that is for each epsilon greater than 0 there exist so two limits. That's why I am taking two natural numbers. The first one is m1 is a natural number such that so modulus of Sn minus L1 is less than, so here epsilon by 2. So why I am taking epsilon by 2 is, so clearly, so L1, L2, these two limits. For suppose S1 is the value which lies here, let it may be Sn. Then what is the distance between these two? Clearly this is epsilon by 2 and this is what? Epsilon by 2. I take Sn as a middle value of L1 and L2. That's why the difference between Sn and L1 is what? Epsilon by 2. So modulus of Sn minus L1 is less than epsilon by 2 for all. So what is n here? A maximum value, and compared to the all natural numbers. For all natural numbers, n is greater than or equal to m1. So for all natural numbers, n is a maximum value. So if n is a maximum, then only it is very nearer to the limit. So how much it is nearer to limit? The difference between these two is less than epsilon by 2. That much nearer it is. When it is possible, n is a maximum value. Now similarly, coming to the second limit, the sequence Sn converges to the limit L2, that is for epsilon greater than 0 there exists. So here I take m2 which belongs to natural number such that, for suppose it is the second limit, take m2 modulus of Sn minus L2 is less than epsilon by 2 for all n. N is what? Which is greater than or equal to m2. Why? Because, so now this one is the first value and this is the second value from 1 and 2. So clearly we have two natural numbers, so m1 and m2. Now I am considering an m, so which is, what is m? So maximum of m1 and m2. So why I am taking maximum of m1 and m2? So see, so our n is greater than m1 here and n is greater than m2 here. But suppose I take like this. For suppose out of these two, m2 is maximum, our n should be like here. So because, so which is greatest among all these two. So here what is maximum from this figure? m2. So n is greater than or equal to m2. In all the two cases, n is very greatest value which is greater m2. So I am taking the maximum among m1 and m2, which means that, so out of these two, what is greatest value? m2. So our n is greatest to the m2. Why I am taking a very greatest value when compared to these two? When n is a greatest value, then only our sequence approaches to the existing limit. So among m1 and m2, what is greater? m2, and our n is greater than m2. See, which means that for all n belongs to natural number, n is greater than or equal to m. So here m is what? Maximum among m1 and m2. So now we have, so epsilon, so what is epsilon? I don't know that is L1 minus L2. So clearly it can be rewritten as Sn minus L2 minus Sn plus L1. So now add Sn and subtract Sn here. So from this I can write it as, so modulus of Sn minus L2 plus L1 minus Sn. Now, so we already know that modulus of A plus B is always less than or equal to mod A plus mod B. So well known formula. Now since it is A and it is B, then it should be like this: less than or equal to modulus of Sn minus L2 plus modulus of L1 minus Sn. Now we all know about clearly. So from this, modulus of Sn minus L1 is what? Less than epsilon by 2, and modulus of Sn minus L2 is what? Less than epsilon by 2. Clearly, so which is less than epsilon by 2 plus epsilon by 2, which is nothing but less than epsilon. So what we have assumed early, that is epsilon. Clearly here, so from this, epsilon is less than epsilon. Is it possible? So not possible, which is a contradiction. So if it is a contradiction, which means that, so our assumption is wrong. So what is our assumption? Our sequence is converges to two limits, that is L1 and L2 is completely wrong, which means that L1 is not equal to L2 is completely wrong. Clearly, if L1 is not equal to L2 is completely wrong, means that is L1 equal to L2. Why? Because our assumption is wrong. What is our assumption? Clearly, it is L1 is not equal to L2. So, why our assumption is wrong? So what we get? Epsilon is less than epsilon, which is always not possible. So L1 is equal to L2. So the limit of a sequence is always unique. Clearly